thought I'd better show you how you get these this tail wheel controls off of the tail wheel. These things are just hardware store screen door springs, but all you have to do is squeeze them together. So if you push the wires inside there, I don't know if you can see that in the camera. You just push that through there and squeeze these two hooks together. Then this thing comes apart. Then you can take, things like this, or things like, if you want to get this spring off of here, you squeeze these together and that'll pull out of there. And then you can take this off. These things are used to limit doors opening. They sell them in hardware stores. I might have put a heavier spring on this. I think I did. That the springs are a little heavier than the ones that come on a screen door, but that was just some modification I made. But anyways, that's how you get that apart. This plug right here, if you unplug that, it takes loose all the instruments, and the instrument panel, there's 4 screws in each corner. You can take the whole panel out if you want to do anything to the instruments or change them or anything. This is the battery box. These are the battery cables that go on it. Go on the battery. You got one for the positive. You'll notice I marked that with a red plus on there. This, of course, is the minus side here. They go inside this box. They're held down with these straps. That's what clamps the battery in the battery box. The shortest lead is this one, and it goes over here to this relay. The starter relay is underneath the seat. The seat mounts on top of here. The reason for that is that way there's no heavy wire that could supply heavy current except for from the battery to this point. This one goes back to the starter motor. It's really long and it's a heavy cable, but it can't start a fire because there's no current in it unless you push the starter button. That's for safety. I'm a little worried about fire. So that's what that's all about. This is a standard starter relay you get at any auto parts store. So that should explain how the starter works on it anyway. This starter switch is made so that you can pull up on the choke, or it's not really a choke, it's a cold start control. Increases the mixture. Reach in the mixture and push that button, and that's going to start the engine, which hopefully you'll learn how to do with just one hand. You can do it. You don't have to undo the seat belt to start it. Always when you start it, hey, are you paying attention? This throttle lever must be all the way back when you start it. That's the way these type carburetors are. The cold start control, the enricher, does not work unless there's enough vacuum to draw the fuel through there, and it can't do it if the throttle's open. So you don't crack the throttle when you start it. You leave it at an idle. That's how it starts. The reason this lever is so long is mostly because I didn't like what they gave me with the kit, and I always wanted a, airliner type throttle. You can set it real precisely. Very small movements you can make adjustments to the throttle. It works through mechanical linkage to the back. This right here, there's a shaft that goes underneath this aluminum plate and goes to that linkage, which moves back and forth, and that in turn rotates this shaft, and that shaft comes over here and pushes this linkage, which works the rear seat throttle. The rear seat throttle is shorter. The reason being, I don't want it interfering with a passenger, or a passenger getting his arm or leg or something in the way when I'm trying to adjust the throttle. So this lever is shorter than that lever by quite a bit, and therefore I don't know if you wanted to train somebody with the instructor sitting in the back seat, he cannot override the front seat. So it's something to consider if you're going to use this plane for training. Now this lever here for the stick is quite long as compared to the one in the back, although not a lot of difference, but it is longer than the rear seat because I don't want the rear seat getting in the way of the passenger back there. I think I explained this before, but this is the trim. It's got a reel of cord on here and cord on there. And it's just like window shade cord, you know, it's just a heavy string is really what it is. And to adjust it, you pull this out. There's a string on it. And there's a pin that locks it so it can't turn. So when you pull it out, you can rotate it. If you rotate it this way, backwards, it's going to lift the nose up. And if you turn it this way, it'll push the nose down. Because it's just a bias on the stick, if you change speed, you're going to have to readjust the trim. You find this knob when you're flying it because the seat's not in there right now. But you find that knurled knob by running your hand down along the seat belt that goes over your lap. You follow that lap belt down and you're going to feel that knob. And that's where you adjust the trim. But when you change speed, you're probably going to have to change that trim. You have to keep that in mind. How these instruments work here. You have a compass on the floor. It's a nautical type compass with a lubber line on it that you can tell which way you're heading, north or south and so forth, and how many degrees. When you turn on the master switch, there's a light that'll come on in here that you can see. That tells you the master switch is on. And this is your water temperature gauge. When you start it, it'll be cold like that, like it is now, but if it runs 2-3 minutes, it's going to be right up to the top of the green and ready to take off. You don't really have a problem on temperature unless you see it get up here to the red. But I don't think very often you'll ever even see it go into the yellow, not unless it's a real hot day. The cooling on this thing is plenty sufficient. This is a tachometer. The revs that you get, it's static before you take off. If you're holding the brakes, you can do a run up, and I usually set it to about 4,000 RPM. That's enough for it to fly, but it'd take you a long time to take off. You'd need a lot of runway if you only were turning 4,000 RPM. But that's usually all I use so it don't strain the brakes or make the wheel slide in the grass. When you take off, you should see at least 6,000 RPM when you take off. Now it'll probably go more than that. 6,500 would be ideal. That's your maximum power about if you get 6,500. On takeoff, as you're climbing out, it's running real good. But that varies between 6,000 and 6,500 due to air pressure, humidity, things like that make it change. This right here is your altimeter, which is settable, just like the ones in big aircraft are. So you can set that to your altitude of wherever the airport is you're taking off. I think I usually set it right there, 1,100 feet, because that's what Mayfield is. So you set that before you take off. These buttons here are for that emergency locating transmitter. You'll see this light come on if it's transmitting. If you hit too hard or something, it's going to set that thing off, and they're going to come looking for you, because that'll transmit on the emergency frequency of 121.5. It doesn't tell them where you're at, but it knows somebody's messed up, and then they find you by triangulation to find out where the signal's coming from. The newer ones have GPS and tells them exactly where you're at. This one doesn't have that. This is the most important one. This is the airspeed. Airspeed indicator is simple. Don't slow down. If you're in the air, don't slow down. Don't go below 50 miles an hour unless you're far away from the ground. You can do stalls with it and everything. It stalls real mild. It just, when it drops, it just goes down straight. There's no big event when you stall it. You have to actually look at the airspeed to tell you're stalled. But if it gets down here, you'll see where this white line is at 40 miles an hour, and that's where it should break at 40. But I don't think you should slow down below 50 if you're close to the ground. Don't go below 50 if you're, unless you're going to land it and you're within a foot of the ground. Don't slow down below that. It's simple. Airplane flies if it's going fast enough. Now, of course, you can stall it if you give a yank on the stick or something. You could have what they call an accelerated stall because you're putting more load on the wings, and it may stall at a higher speed than 40. But it will fly at 40 if you put the flaps all the way down. I've flown it at 40. It flies real nice at 40, real slow, so you can fly along at 40 miles an hour if the flaps are down. Your VNE is supposed to be, I think they said 112 or something, but I never had it going that fast. 95 is as fast as I've ever had it going in level flight. It'll do 95 miles an hour. But most of the time I'm flying about, I'll say between 65 and 75 miles an hour, right in that range. So the needle's pointing like this. Now these buttons here, this is an overheat light. If the engine lost coolant, or for some reason that coolant got too hot, when it gets up to about 190 degrees, I tested on a stove, but there's a switch on the engine that'll turn this overheat light on. This other one is fuel transfer. So when I'm transferring fuel from the football tanks into the main tank, there's a little pump mounted on the root tube. I'll have to show you that. But this light will come on when that's running. You might be able to hear it even, I don't know. It makes kind of a flutter noise. It's a ultralight type fuel pump. But you just set there's a diverter valve. I'll show you how that works. And you set that to point to the tank you want to suck the fuel out. So it's kind of mid-flight refueling. In-flight refueling is what I'd call it. The engine can't get to the football tanks. That fuel line doesn't go to the engine. It just goes to a valve that pipes it into the main tank. So it's in-flight refueling, that's what I'd call it. The range on it's about 425 to 450 mile, maybe 475. Depends if you got a tailwind or you know what the winds are, but it should go about 450 mile without, you know, before the engine quits. You know, you want to have a little bit of reserve, but that's I'd say is the range of this thing with the tanks, if you put all the tanks on them and fill them up.